Hello, here's a quick demonstration of a continuous random variable question in the MEI S3 syllabus, and I'm going to use the January 2007 question 1 as an example. This is a classic setup. Okay, as ever, the first thing we do is read the question. A continuous random variable x has a probability density function f of x, and that's defined there, for the range, yeah, so they've given us a range 0 up to 1, where k is a constant. Okay, let's have a look at part 1. Show k equals 2, sketch a graph of the PDF. So let's start with that, shall we? Okay, so f of x equals, so number 1, f of x equals k of 1 minus x. So what is it that we need to do? We need, or use what property? Well, we need to use the property that the total probability equals 1. It's always equal to 1, and we calculate that probability for a continuous random variable by calculating the f of x, integral of f of x dx, from the minimum in the range to the maximum in the range. In this case, we've got k to the 1 minus x dx, and the range is 0 to 1. And if we just integrate that, we can take the k out the front, can't we? And we integrate what's in this bracket here, and we get x minus x squared over 2. And it's a definite integral between 0 and 1. So the upper value is going to be 1 minus 1 over 2. And the lower value is 0. So in this case, I'm just going to leave that as a 0. Yeah. And so that equals k over 2. So that's what the integral equals. And we know that that must be equal to 1. Yeah. By definition, total probability is 1, and therefore k equals 2. So that's the first part, and they then asked us to sketch the PDF. So here's some axes, and we found, oops, should be on pen. We found that f of x equals 2 times 1 minus x, yeah? So what do we know about that? Well, when x equals 0, f of x equals f of 0 equals 2. That's one end. It's a straight line, isn't it? And when f of x equals 1, f1 equals 0. So we've got a straight line here going from the point f of x is going to be 2 here, and over here we've got our maximum of our range is 1 value, and at that point the value is 0 of the f of x function. So if I just draw that quickly as a line, there we go. There's our function, and just being a bit more precise about that as a line, it only goes from 0 to 1. Here we are, makes it a bit clearer, doesn't it? Here we go, that's a 0 there, and there's a 1. So there's our sketch. And the important thing here is, probably in the mark scheme, is we need to show that it's gone through effectively 0, 2 here, and 1, 0 there, yeah? Happy with that idea? Then let's go on and have a look at part 2. Part 2, find e of x and show that the variance of x is an eighth. Okay, so part 2, give ourselves slightly more. Well, we know f of x is now 2 times 1 minus x, yeah. The expected value of x, that's what that means there, that's the mean, and that's going to be the weighted average with probability, so it's going the range from 0 to 1, and it's x times f of x. we're finding the weighted average of x. So there's our probability, and it's going to be the 2 out the front, and I've got an x and 1 minus x inside dx, 0 to 1, which I'm sure you'll, even on S3, a lot of you will recognise that that is x as first term, so that's x squared over 2 when it's integrated, x squared for the second term, so it's x cubed over 3 when integrated, and we're integrating again over the full range from 0 to 1, and therefore looking at the upper 1, it's going to be 1 minus a third, and when x equals 0, so the lower is going to be 0, and therefore I've got a half minus a third is a sixth, and therefore the expected value is 1/3. That makes sense. Get back to our sketch, doesn't it? That actually that's where our mean's going to be over here. Okay, here we go. And the second part they asked us to find was to prove that the variance is an eighth. Variance, the expected variance is an 18th rather. The definition of that is, I'll find the variance, we use our formula, it's the expected value of x squared, and then we're going to subtract the expected value of x all squared. And we know that the expected value of x is the integral of x squared f of x dx over the full range, 0 to 1 in this case, and here we've got an x squared, we've got a 2 we can bring out the front, and 1 minus x from our PDF dx, 0 to 1, there we go, which is going to give us 2 times, here we've got x squared is our first term, so that's the first one integrated, the first term is going to be x cubed minus 3, here we've got x to the 4 over 4, 0 to 1, which are 2 lots of 1/3 minus 1/4. That's 2 lot times a 12th. There we go. So that's a sixth. Are we happy with that? So e of x squared is going to be a sixth, and therefore the variance of x is going to be the e to the x. Let's just write it out so we can all see it again. Minus e of x, expected value of x all squared. So we've got, that's a sixth minus the square of a third. There we go. So we've got a sixth minus a ninth, which equals an 18th. There we go. So that's variance of x. So that's the first part of this, first 2 parts done. Let's hop up and get to the next part quickly. It's quite a long one. Derive the cumulative distribution function and hence find the probability that x is greater than the mean. Okay, so let's do that. Okay, 3, derive CDF. Well, our definition of CDF, we've got a big F, don't we, in the notation, is the integral from 0, our minimum, to x of our PDF, and in this case that is 2 times or 1 minus x, but we want to use a dummy in variable, so we're going to call that u, du, and we're going to do it to u, and therefore rather than dx, and therefore I've got 2 lots of, if we integrate what's in the bracket, that's x for the first one, so it's not x squared, it's just x. I'm getting that wrong, aren't I? That's actually a u, isn't it? Let's do it again. 2 times, inside the integral I've got a u, the first term, and the second one I've got a u squared minus 2 from 0 to x, which is going to turn into 2x minus x squared over 2, which equals, so our f of x therefore is going to equal 2x minus x squared. And if I quickly sketch that, we would see that that's going like this. It ends up at 1, doesn't it? There's our upper limit. It's got to have a value of 1 at the upper limit, and it's coming from 0 there, isn't it? Because it's got to be the lower limit. That's x, sorry. and that value is 1. So there's our f of x. They've asked us to find the probability that our value of x is greater than the mean, which we know is greater than a third. We've done that already. And the best way to do this is if we can use this f of x function here. Well, we know when it gets to the total, what they've asked us to do is to find this probability here. That was a third. That's the area we're trying to find, which of course is 1 minus the probability below a third, which is f of a third. There we go. Which equals 1 minus, let's put it in there, 2 of 1/3 minus x squared, isn't it? That's 1/3 all squared. There we go. Which is 1 minus 2/3 plus 1/9, which equals 4/9, yeah? So that's the probability we were looking for. Probability that x is greater than mu is 4/9. Okay, let's carry on then. We're nearly finished on this one, aren't we? We've got quite a few marks here. And what's our final bit of this? Let's do it in purple. Verify that the median of x is that value there, 1 minus 1 over root 2. So how are we going to find our median? That's our final part. I can't remember what the number is. I'm going to call it 5. Is it 4 or 5? Correction, 4. So how am I going to find the median? Well, the median value of x is going to be when f of x is a half, yeah? Half above, half below. That's the probability below it is a half. So substituting for that, I've got 2x minus x squared is going to equal a half. Therefore, x squared minus 2x. If I bring this over to this side, in effect, I've got that as a half. So completing the square, I've got a minus 1 squared there in the square. So I've got to take off a 1 squared, add on a half. There we go. So x minus 1 all squared is going to equal a half. Therefore, x minus 1 equals plus or minus the square root 2, 1 over square root 2. Therefore, x equals 1 plus or minus the square root of 2. Now, we've got to choose which one of those is, but we know the range here, the range, in this case, was from 0 to 1. Therefore, the only root, the solution to this median that is in the range is the minus 1 over root 2. Just tidy that up slightly because that's not very helpful. So therefore we have reached our conclusion. Therefore the median of x, median x equals 1 over 1 minus root 2. So there you have it. Sorry. Just stay there just a sec so you can see it. There we go. So that's the median 1 over root 2. So that's a classic question. Quick summary then of what we've done in this. Firstly, you quite often get asked to find the k value, and we're doing that by setting the total probability to 1. Then draw a sketch, make sure that you put in the coordinates of max and min. And when you're doing that, we can find any probability for continuous random variable by doing the integration from the lower to the upper limit. So that shouldn't be there. And we know how to find our expected value because we're just integrating x weighted by the probability PDF function. We know how to find our variance because we do the same for the e to the x squared here. So we're finding x squared weighted by our f of x, and then we're taking off our expected value squared. Cumulative density function we can find by integrating our PDF from the minimum value up to x using a dummy value du to make clear what we're doing. And the median is going to be when that value of f of x, the value of x for which f of x is a half. So there we are. I hope that's of use.